So in the last video I taught you how to find the number of valence electrons 3 different ways. Now what that's good for is drawing electron dot diagrams or Lewis dot structures. Because valence electrons are involved with forming bonds, chemists can represent them visually using an electron dot structure diagram. So the electron dot diagrams consist of the element symbol, which represents the atomic nucleus and all the inner level core electrons. And then it also has dots, which represent the atom's valence electrons. So here's how you write an electron dot diagram. First you write the element symbol, then you place dots representing valence electrons one at a time on the 4 sides of the symbol. You then pair up electrons until they're all used. So let's do an example here. Let's do lithium. So first we write the symbol. Lithium, of course, is Li. Next we need to determine how many valence electrons lithium has. So one way to do this is do an off-ball diagram. So lithium has 3 electrons, so we fill in the 1s, up, down, and then the 2s is just up. So the configuration is 1s2, 2s1. So its highest energy level is its second energy level, and it has 1 electron, so it has 1 valence electron. So here's lithium, and we determine how many valence electrons it has, and we did, which is 1. And you place a dot for each valence electron. Now you can start anywhere. On the top, bottom, left, or right. It's completely up to you. There's no wrong way to do it. You then put that dot in and you're done with this one. Okay, let's do calcium. First we write the symbol. Calcium is capital C, lowercase a. Then you need to determine how many valence electrons calcium has. So you could do an off-ball diagram and more simply just look at its position on the table. So calcium is in group 2. And everything in group 2 has 2 valence electrons. So we draw 1 dot here. You can start anywhere on the side like I did, or up or down or left. And then the second dot is paired up. Now some people will say that you can spread them out. Some people say you have to pair them up. According to the regents, you could do whatever you want. If this was a multiple choice though, and they wanted you to pick the correct one for calcium on the New York State Regents, it would look like this. Because remember, those electrons are in an s orbital, and the s orbital can fit 2 before it moves on, and they have to pair up before they move on. So this, drawing them next to each other like we are in this diagram is showing those electrons pairing up before moving on to the next orbital. Okay, next we have aluminum. First we write the symbol, aluminum. Determine how many valence electrons aluminum has. If we find it on the table, it is element 13, so it is in group 13, which means it has 3 valence electrons. So you draw the dots one at a time. The first 2 pair up because it has an s sublevel that is filled before it moves on to 1 electron in the p sublevels. And there's the third one. Now if you spread them all out, you didn't pair them up on this side here. If you put 1 here, 1 here, and 1 here, you'd still get it correct as far as the New York State is concerned. But this is how it would be done correctly. Next we have carbon. We write the symbol for carbon, which is C, and figure out how many valence electrons we need to draw. So if you find carbon, it is in group 14, which means of course it has 4 valence electrons. Now we spread them all out. We don't pair them up anymore. 1, 2, 3, 4. Next is phosphorus. We write the symbol for phosphorus, which is P. Find phosphorus on the table, element 15. It's also in group 15, which means it has 5 valence electrons. So then we draw the 5 dots representing those 5 valence electrons. 1, 2, 3, 4, and now we've run out of room. We need to pair them up. You can pair them up wherever you want. It does not matter. I like to pick one side and go clockwise or counterclockwise and do this, but you can draw that paired one up anywhere you want. I'm drawing mine on the right. Next we have sulfur. Sulfur is S. We find sulfur, it's element 16, also in group 16, which means it has 6 valence electrons. So 1, 2, 3, 4. We've run out of room. Now we need to start pairing them up. 5, 6. There's 6 valence electrons. Now you can have your 2 paired like I have, or you can have them on the top and the left, but what I don't want you to do is have the 2 paired on opposite side. When we start drawing bonding structures, you'll see that that would result in an incorrect bond. You have to start and go either clockwise or counterclockwise. If you drew them side to side, it would leave a bond being able to go up and down, and that doesn't happen in elements like sulfur or oxygen. They bond on angles, and they do so because they have a free electron here and one here to share, but these two aren't to be shared easily. Okay, next we have fluorine, which is element F. It has 7 valence electrons because it's in group 17. And we draw our 7 dots. 1, 2, 3, 4, 5, 6, 7. And we have 3 pairs of electrons and 1 unpaired. Again, you could have that unpaired electron on the top like I have, or on the bottom, or the left or the right. It does not matter. Last, we have neon. Neon symbol is Ne. Neon is element 10. It's in group 18, which means it has 8 valence electrons. So when you have 8 valence electrons, all you do is you fill them up. You should follow the rules and go clockwise or counterclockwise, but they eventually will all pair up. 7 and 8. So let's do some practice here. Pause the video and try to draw the electron dot diagrams for all the atoms you see here, and when you're ready, unpause it and I will show you the answers. Okay, here we go. So magnesium has 1, 2 valence electrons. Oxygen, 1, 2, 3, 4, 5, 6. Bromine has 1, 2, 3, 4, 5, 6, 7. Rubidium has, I believe, just 1. Yes. Thallium has 1, 2, 3. Neon has all 8. So I'm violating my rule I just told you, but they are all filled in, all paired on all 4 sides. And tin has 1, 2, 3, 4. How'd you do? Hope you did good. It's not too hard, is it? So, to write an electron dot notation for any element, first you need to know the number of valence electrons, and you should know 3 ways to do that. Most easily, though, its position on the table or its configuration in the lower left-hand corner. You then draw dots around the symbol of the element, 8 max, and for most elements, you don't pair up the electrons until you have to. And like I said, this skill will become useful later when we're drawing compounds. All of these things that we're learning are little skills that are building on top of one another. We learned how many valence electrons there were, so we could draw electron dot diagrams. And now we're learning how to draw electron dot diagrams because in chapter 8, we're going to start drawing bonds of structures and the angles of bonds. And you need to know this skill before you can do that skill. So if you're having trouble with this, please let me know and ask questions because it's not going to go away, and if you don't understand it now, you won't be able to do bonding later. So I hope this makes sense. I hope this is easy. It probably is. And if you have any questions, though, please let me know or come see me for help.